exercise B, okay, largely based on looking at the types of numbers we have, even and odd specifically, okay, that is going to help us with our deductions. So what we're going to do is we're going to look to sort of understand algebraic expressions for odd numbers and for even numbers, okay. So this can be done quite simply if we just consider the sort of numbers, okay. And when I mean numbers, we're going to start off with, say, 0, and then we're going to increase by 1 each time. So these would be known then as the integers, going from 0, 1, 2, 3, 4, 5, 6, and so on, right? Now I'm going to call this n, right? Because n represents numbers, isn't it? So when n is 0, okay, or when n is 1, or when n is 2, n is 3, 4, 5, 6, 7, and so on, right? 8 all the way, right? Now let's think about it, okay? We've got an expression for the counting numbers here, okay, using 0. We've got the expression here, and we've just got the expression n, yeah. N represents these numbers. For even numbers, okay, and we need an expression for just the even numbers, okay. It can't be n, can it? Because n represents both even and odd. Okay, so I just need an expression just for the even numbers. So let's think about this. We can actually establish an expression just by taking these values here. Now, if you think about it, these numbers here, if I double them, okay, if I double them, look what happens. If I double 0, I get 0. If I double 1, I get 2. If I double 2, I get 4. If I double 3, I get 6. Double 4, I get 8. Double 5, I get 10, and so on. If you notice then, by doubling the counting numbers up here, I get the even numbers isolated. I just get the even numbers. The odd numbers disappear, okay, just by doubling it. So all I've done is I've doubled these numbers. So in terms of an expression, I say, well, it'll be 2n, won't it? Okay, because I'm doubling n. So that would be my algebraic expression for even numbers. That sort of represents the 2 times table, if you want. Now, for an expression for odd numbers is really simple, and actually we can use this here to help us, because if you look here, these are our even numbers. Well, I can establish the odd numbers from these by doing something. Now think about it. What could I do to these to get to the odd numbers? Well, if you add 1, yeah? If you add 1, you're going to get the odd numbers, aren't you? So if I add 1 to each of them, here, it simply becomes the odd numbers. So I'm going to add 1 to the even numbers, means I'm going to add 1 to that expression. So an expression for odd numbers will be 2n plus 1. Is that okay? So we've got an expression here for odd numbers, an expression here for even numbers, odd and even there. Okay, that's a general expression. Now, if we wanted to choose a specific even number, right, somewhere down the line, but we didn't know what it was, we could say an even number represented by, say, 2k. Okay, we don't have to use n, okay, because that's sort of like the general representation of them. So we could use 2, we could say like the even number would be 2k for a specific k, yeah, for a specific k. Now, if we wanted to get a different even value, then we'd obviously use a different letter, yeah. So we could say 2p, okay. We use different letters there. And the same thing for the odd numbers here. 2k plus 1, for instance, would represent for a specific k. But if I wanted a different odd number further down the line, I'd use a different letter, 2p plus 1, okay. Now, when it comes then to consecutive even numbers and consecutive odd numbers, you just need to appreciate here that consecutive means next to each other. So, for instance, go back to the table here. If I look at the consecutive even numbers here, well, 4 and 6, they're consecutive even numbers, yeah? Or 8 and 10, they're consecutive, they're next to each other. Now, if you think about it, to get a consecutive even number, to get the next one, you've just got to add 2 onto the previous one, haven't you? So these are consecutive. To get 14, I've just got to add 2 onto that. So if I were asked for consecutive even numbers, if the first even number, for instance, would be 2k, the next one then would be 2k plus 2. Okay, because you're moving 2 along, so that would be an expression for it. Similarly then for consecutive odd numbers, okay, if I had my odd number 2k plus 1 to represent a certain odd number, the next one along would be 2k. Of course, I'd add 2 onto it, wouldn't I, to get to the next odd number. So if I add 2 onto that, I'd actually get 2k plus 3.